Mr. Will, what kind of work do you do?
I'm a janitor.
You're a janitor. Mr. Andrus, I already know what you do. Electronics. Engineer. HR.
Gun mechanic.
Gun mechanic. Seismic. Engineer.
Subsea.
Subsea.
Navigation.
Navigate. Subsea Steve with who? Pacific.
HES.
HES.
Engineer.
Engineer.
Subsea.
Subsea.
Engineer.
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 Any Texas A&M guys here? Yeah.
I'm sorry.
Hey,
What'd you say, Josh?
No, I'm sorry.
Appreciate it. It is what it is, though. No, you guys have so many different diverse backgrounds where it can actually add to the presentation. So if you guys see anything that you would like to add, any information, especially when it comes down to your specialty field, when it comes down to your field, you guys can add as much information as possible. I don't have a challenge with that whatsoever, okay? However, I have strict guidelines that I have to remain within. With the industry and installation overview, the formation of our hydrocarbons. With your formations, can anybody tell me how hydrocarbons are formed? There's different theories out there. We want to take a look at one. That's most referenced. Well, let me ask you this. Where do we get our hydrocarbons from?
Peat moss.
Peat moss. That's one. What'd you say?
Dinosaurs.
Dinosaurs. That's a good one. Come on, Charles. I see it right there.
Any kind of decaying organic carbon-based matter?
Look, you got all these big words right there. You and you wouldn't put it out there.
Didn't even go to A&M.
Yeah. You got to smile at him. I knew he knew it. He's sitting there like, yeah, I got this one. Just spit it out there. Dinosaurs, peat moss, plant, marine. We have decaying matter. Let's just say marine, plant, and animal life. Let's just say they died. When they died, they settled at the bottom of the ocean's floor. When this began to take place, you have an original layer forming here. As time went on, continued time went on, you got a secondary layer, a rocky or sedimentary layer that began to develop. The second layer formed on top of the first layer. With these two layers here, what do you guys think began to take place?
Compression.
Compression. With compression, what is normally generated?
Heat.
Heat. With the generation of this heat, your organic or original layer is then converted into what is known as your hydrocarbons, so to speak. That's roundabout a simple explanation of how our hydrocarbons are formed offshore, given this body of water here. What about on land? Who can tell me how they get on land? We do have formations on land. Same thing. Same thing. The Earth's country, the Earth's crust is made up of, how can we call it? Tectonic plates. Some of you guys may refer to it as a migration theory. Tectonic plates. You had huge masses of land that were once below sea level. They're now above sea level now. Your tectonic plates are constantly shifting and moving. The moving of these plates, we can feel them in the form of volcano eruptions, tsunamis, earthquakes, different things like that. Masses that were once down here, they're now above here. Your onshore hydrocarbons, so to speak, they're actually used as tourist attractions in some spots. For example, you have the La Brea tar pits in California. In Trinidad, you have the Pitch Lake toppings. And someone's been telling me about a formation in Alaska, but I have yet to find the formation that this guy was telling me about. However, for the likelihood of hydrocarbons to be present, you need certain things to be there. The organic layer, which we already discussed, that original layer. You need a porous rock bed, a suitable trap, and you also need what is known as your rock cap. Your rock cap is very integral in this process. The rock cap, it minimizes the escape of your hydrocarbons to the surface, so it kind of maintains the positioning of your hydrocarbons, so to speak. Without the rock cap, you guys remember from, not this April, last April, you guys remember, excuse me, the Deepwater Horizon. Remember how, when you see it on the news, how the hydrocarbons just freely flowing to the surface, it seemed like they're freely flowing to the surface. Without your rock cap, this process can continue on a regular basis if we didn't have the rock cap maintain the position of our hydrocarbons. So that rock cap is very important. Now we know what needs to be in place for the likelihood of hydrocarbons to be present. We have certain things in place that is preventing us. Let's just say all 16 of us, all 17, 18 of us. We gather some equipment, money, the proper personnel. What's in place to prevent us from trying to tap into our own main reservoirs? Let's just say out there in the Gulf. Government. We have licensing agreements. These territories, the Gulf, those waters, they're divided into blocks. Those blocks are often put up for bid. Before you can begin any type of exploration process, you have to actually bid on these blocks or submit a proposal in pertaining to the information of these blocks. In your proposal, you need to include environmental information. How are we going to be environmentally safe? Or how are we going to offset some of the hazards that present themselves from us exploring? Economically, we need to talk about how many of the locals we'll be able to employ. Will we be able to employ any of those locals? Then we need to talk from the governmental standpoint. What do you think the government is interested in? Yeah, royalties. How will they profit or how will they benefit from our exploration process in this land? In this area. Let's just say we win the bid, so to speak. We get the primary survey of the block. It's a primary survey. How will we go about pinpointing the exact location of our hydrocarbons?
Seismic survey.
Your seismic. We need to go through what is known as seismic. Can anybody explain your seismic survey for me? The way the process works. What you got, Josh?
There's a couple different ways of doing it, but
You work for Fairfield?
yeah.
Come on. When they say there's a couple of different ways, because they haven't. Go ahead.
Basically, you're using a source, just an air source. You'll shoot those off, and the sound waves travel through the water, through the rock bed, and they'll bounce off kind of like a sonar through the different layers of rock bed, and give you a 3D image of what's underneath there. And that's how you can tell the oil is.
Perfect. Perfect. Can you explain the nodal process?
Well, using nodes, they are placed on the bottom of the seafloor. Still using you have a source code or a couple of source codes which will go over them, shooting at specific increments. Sound waves are still traveling down, and they're caught, and all the information is collected right there at the seafloor. You don't have to wait for it to come all the way back up. So it's less filtering, gives you a better image of what's underneath it.
Perfect. Thank you so much. Anything you want to add, sir?
No, I was just going to say the nodes are so much simpler than the lines.
A lot simpler. A lot simpler.
You don't have to deal with streamers anymore.
Mm-hmm. The streamers that he's talking about, guys, is attached to your survey, and they have hydrophones attached to them. And the hydrophones is what's captured their information to analyze it. If they were on land, they would use the geophones, so to speak. And so, thank you guys. Thank you so much. Now, if the likelihood of hydrocarbons are pretty high, what do you guys think we're going to do? Yeah, read it. Read it. There's a lot of different pieces of equipment that can be used in this process. The first thing I want to take a look at is my jackup. By definition, your jackup drilling rig is a steel barge on a set of retractable legs. Your jackup can either be towed out or thrusted to its site. Once you get to the site, the barge is then jacked up on the legs. But since it's retractable legs, what do you guys think the number one limitation you can face would be with your jackup? Height, depth, water depth? Yeah, water depth definitely is one. I think we're looking at, 500 feet at the max, I think. More common, we have what is known as our semi-sub. Anybody know anything about your semi-subs? Your semi-sub drilling, what you got, Josh? No, come on with it. You're helping me out, trust me. Okay.
They have a couple pontoons on them, and they use ballast tanks to submerge it down and keep it at a level playing field.
Mm-hmm. Your semi-sub, just like you said, have pontoons or submarines, so to speak, that can aid in the positioning of your semi-sub. You also can, it can maintain its positioning by sea anchors, wire ropes, winches, a combination to make sure that it maintains its position. Your newer ones, they use a system known as your DP system, your dynamic positioning. Can anybody explain dynamic positioning for you? Thrusters. That's one. Charles, what you?
It has it's computer controlled, and it maintains its position over the well. It has in the software a watch circle where if it does drift out or if it does drive off, it will disconnect from the BOP stack. But it can rotate to compensate for currents.
That's perfect. Thank you. Satellite linkage. Maintain its position. Normally manned by DP operator, badge operator, depending on what your company prefer to call it. From a mobile standpoint, we have what is known as our drill ship. Your drill ships, you can even have some huge drill ships, some large drill ships, up to what, 1,200 feet in size, VLDSs. They can contain up to 2 derricks. They can go through. They can do a process known as dual activity. They can actually do dual activity or have dual function, so to speak. Transocean, as a matter of fact, Transocean. I can't remember where this drill ship is at. Do you have any Transocean guys in here? Transocean jets, they reach what 12,000 feet water depth recently, and so they actually have a couple of those drill ships out there that they got some pretty good water depth with them from a mobile aspect. Let's just say we cap off our well. We've tapped into the well, we cap it off. Now I want to bring in some production units. The first I want to take a look at is my steel jacket. Your steel jacket platforms, normally constructed on land. What's first brought up to the site is these steel tubulars that you see down there. Your steel tubulars embedded into the ocean's floor, the seabed floor, and then you have a top side that's mounted on to those steel tubulars. Vehement of a structure we have is our concrete gravity. Your concrete gravity, not only does it, how can I put it? Not only is it concrete, but it is also steel reinforced. You have your ballast tanks, just like one of you guys were talking to us about earlier. You have your ballast tanks that can be flooded. Your concrete gravity, though, they also can contain or have storage tanks, because not only can they produce, but they can store also some of your concrete gravity bases. From a mobile aspect, we have our FPSOs. What do you guys think the FPSO does? Storage. What else? Processes. And we can offload. We almost had on 3. We can produce, we can store hydrocarbons, we can offload to nearby tankers. You can work areas with multiple wells. There's a lot of different processes that can take place with your FPSO. Anytime there's a vessel, the type of vessel it is will tell you their functionality, and you guys will see in just one second. You have different specialist vessels that are out there performing work as well, while we're performing our types of work. Here's just a substructure of what's going on below sea level with your production platforms or your production vessels. Like I said, for example, if you saw the name Flotel, what do you guys think a flotel did? Flotel.
Floating on top.
Thank you. Floating up. It says a floating hotel. Thank you. Let's try one more. Let's try one that's a little bit easier. What do you guys think a pipeline vessel does? Okay, thank you. You guys had me worried there for a second. Your flotels provides additional accommodation. You have various ways to transfer depending on where it's located. And then you also may have your additional onboard facilities to include your rec rooms, your barns, more advanced medical facilities, additional helipads, different things like that.